Assalamualaikum and hello everyone. Welcome to the video for 4.4 reactions in organic compound. This video we will learn to define electrophile and nucleophile as well as Lewis acid and base. Next we will learn to state the main type of organic reaction, which is addition, substitution, elimination and rearrangement. And we will learn to identify the main type of organic reaction given an equation. So let's look at the definition first, which is on your notes on page 15. Okay, so first, what we're going to learn is actually the definition of electrophile. So what is actually electrophile? Electrophile ni maknanya dia electron, file tu maksud dia light. Okay, so electrophile is a species that love electron. Okay, however, a species that love electron tu adalah electron poor species. Dia macam dia opposite attract gitu. Tak adalah macam ni. Electrophile, senang nak kata dia adalah, contohnya kita kata dia adalah kaki perempuan kan, maknanya suka perempuan, kaki perempuan ataupun womanizer kan. Tapi kalau kita define that person as womanizer, usually we call a man lah kan, a man to be the womanizer ataupun lelaki lah yang kita kata kaki perempuan tu. So samalah juga macam ni. Dia likes the electron, but dia likes electron tu sebab dia tak ada electron. We will always like what we don't have, macam tu. Okay, for the electrophile, it can either be a neutral or a positively charged. Okay, because for a positively charged molecule ataupun atom, it means that it has donated the electron kan. So once it donated electron, dia dah poor, electron poor species. So that's why lah, neutral ataupun positively charged ni is an electrophile. Okay, an electrophile is also it can also be defined as the electron pair acceptor. Okay, electron pair acceptor is the other name for it is Lewis acid. Okay, for example, we have AlCl3 here. So for the aluminium, as we can see, it is bonded to 3-chlorine. So even though this is actually is accepted, because remember aluminium is example of bubble, incomplete octet, but actually the aluminium still can accept 2 more electron to achieve octet. So again, so it means that this species is an electron poor species, tak cukup 8, so it can be your electrophile. Okay, lastly, electrophile is where your low electron density carbon. Okay, what does it mean by low electron density carbon? It means that it is a positively charged carbon atom or carbocation. Carbocation yang the carbon contain a positively charged. Okay, so the example for it is this 3 functional group. But even though kat sini kita tengok mana ada positively charged, where's the positively charged? Okay, but then we know that in the element, it will have different electronegativity. Across the period, electronegativity increase. Okay, so contohnya dekat sini, between carbon and oxygen, oxygen is more electronegative. Between carbon dengan halogen, which is your group 17, halogen is more electronegative. Okay, and then we know that maknanya this group 16 and 17 ni has higher electronegativity. So it means that it has higher ability to attract electron. So even though it seems here that they share, for example here they share 4 electron, but actually the electron are more concentrated towards the oxygen. So that's why lah dekat carbon ni, it will be a low electron density, or ada name for it, we call it as carbocation. Okay, for this one, please in your notes, we will call it as electrophilic site. Okay, why electrophilic site? Okay, because actually later during the reaction, we're going to learn more about our electrophile and nucleophile. Tapi electrophile ni dia ada endless possibility. So sometimes it will be easier for you to know the site ni. It's okay. Later we're going to look at the examples. Okay, so this is for electrophile. How about the nucleophile? Okay, nucleophile again, file maksud dia is like lah. Nucleon is actually from your nucleus. So it means that they like yang positively charged benda lah. So here, so what does it mean is that it is a species that love nucleus. Okay. So when it loves the positive one, so maknanya dia sendiri banyak negatif lah, ataupun electron rich species. Again, we will always like what we don't have kan, macam tu lah. Okay, so for a nucleophile, it can either be a neutral or negatively charged. Okay, sebab dia dah electron rich kan? So, apa ni? So, it would leave the nucleus. So, that's why negatively charged, an easy hint lah to know that it is a nucleophile. And electron pair donor ataupun ataupun Lewis base itself is actually an example of your nucleophile. Okay, remember that NH3, when we draw our NH3 here, we do have lone pair on the nitrogen. And for the water, actually we have two lone pair. So what happened here is actually this electron pair, it means that it is electron-rich species. Okay, and then when it is electron-rich species, actually it can be donated. Okay, so that's why it is your nucleophile. Love nucleus, sebab dia dah banyak electron kan? Okay, and then for the nucleophile is where it will have a high electron density. Okay, it means that the electron-rich areas, such as carbon ion is carbon that have negative charge on it, the double bond and the benzene ring. Okay, for example, for our alkene itself, kan here 1, 2, 3, 4. So maknanya in this case, between the alkene ni, banyaknya elektron dia. Between alkyne ni, we have 1, 2, 3, 4, 5, 6. Lagilah rich with electron. Benzene ring ni pun sama juga. 1, kasi 1, 2, 3, 4. Sini, it is rich with electron. Okay, again, for this case, I would call it as, this one is nucleophilic site. Okay, so that is actually the definition for our electrophile nucleophile. Next, what we're going to look at is actually the reaction itself. Okay, so let's look on page 17. The type of reaction kita kena tengok adalah addition. So addition is actually when atom is added to the adjacent atoms of a multiple bond, be it double or triple bond, and only one product is produced. And the addition ni can be divided into two, which is electrophilic and nucleophilic addition. So let's look for the electrophilic addition. They initiated by an electrophile. Okay, so and then okay, senang sebenarnya nak tahu site lagi sebenarnya, sebab nucleophilic site, electrophilic site is limited. Okay, so here kita punya alkene is actually, alkene kita ni rich dengan elektron, so that's why dia adalah nucleophilic site, and electrophile adalah poor electron. Okay, so again, kenapa dia rich? Sebab adanya banyaknya elektron pada double bond itu. Okay, so contohnya kita tengok, so this is attack by electrophile, tapi Miss senang nak buat, Miss buat expanded lah bagi kamu nampak lagi what is actually the addition reaction. So contohnya ini adalah kita punya reactant as well as our product. Okay, so tak cukup. Okay, kita nampak kat sini bromine is added to carbon. Okay, sebab kita ada 2 of our Br. Okay, and then the electrophilic addition is actually typical reaction of unsaturated compound, unsaturated, such as alkene and alkyne. Alkyne ada triple bond. Okay, next kita tengok adalah nucleophilic addition. So dia adalah, okay, again, oxygen high electronegativity, so that's why dia ada partial negative, and carbon dia adalah poor electron, poor species sebab dah elektron banyak pada oksigen. Okay, and HCN ni is actually dia asalnya daripada H plus dengan CN minus. So CN minus ni is actually, tengok, dia adalah nucleophilic species sebab dia adalah rich electron, so dia nucleophile. Dia yang kita add pada our carbon. Okay, so H2 pula added pada oxygen. Okay, so for nucleophilic addition is the typical reaction for carbonyl. So next kita tengok adalah substitution, which an atom is substituted ataupun kita kata replaced by another group or by another atom ataupun group of atom. Okay, so tapi kalau substitution ni ada 3 jenis. So let's look at the first one, free radical ni. Okay, Miss senang buat jadi expanded lah supaya kamu nampak. Okay, so dekat sini, okay, the hydrogen is substituted with our chlorine. Okay, so tapi kalau sebab dia adalah free radical substitution, so substitution reaction ni involve free radical as our intermediate species. Macam mana nak tahu dia free radical? Hint dia adalah from our UV. So next kita tengok adalah our electrophilic substitution. So kita punya benzene ni is rich with electrons. So bila dia rich electron, dia adalah nucleophilic site. So if you be unsure what is the site ni, tengok balik nota on the previous page. Okay, and then kita tambah dengan Br2 which is our electrophile. So kita tengok hydrogen ni is substituted with bromine. So substitution lah. And electrophilic substitution ni is actually typical reaction of our aromatic compound. Aromatic ni ataupun benzene lah. So for example, sebab benzene ni has high electron density. So that's why the electrophilic substitution. Next kita tengok nucleophilic substitution. Okay, yang saturated organic compound ni maksudnya ada single bond saja. Itu means saturated. Okay, kalau unsaturated double or triple bond lah. Okay, typical reaction ni bearing polar bond as our functional group. So what does it mean by this? Okay, so for example, I'm going to draw my haloalkane dekat sini. So carbon ni attach pada chlorine lah for example Okay. So as we can see here, it's actually dia ada different electronegativity. So chlorine ni is more electronegative lah. Lemak ni pula. Okay. Tersilap. So betul kan? Yang electronegative tu kita letak negative charge. So it is more electronegative. Carbon kita ni sekarang ni jadi poor electron. So bila dia poor electron, maka dia adalah electrophilic site. Okay. And it been substituted dengan nucleophile. So that's why dia adalah nucleophilic substitution. So addition dengan substitution, dia ada detail lagi. Kamu kena detailkan lagi lah. Addition ada 2, substitution ada 3 jenis. Okay. Second last kita tengok elimination is actually which atom ataupun group of atom are removed ataupun eliminated from adjacent carbon atom to produce double bond ataupun triple bond. So double atau triple bond baru unsaturated. And then, so kita tengok this is for the case of dehydration of alcohol. Okay, so kita akan buang air kita ni lah. Okay, apa yang akan tinggal? Alkene. Okay, and another product tu adalah kita punya water which has been removed from our alcohol. Okay, last but not least is the rearrangement where we're going to rearrange to form new molecule. Yang A ni kita tengok kita punya straight chain jadi branch. Okay, yang B ni pula kita tengok okay, functional group tu berubah position. So kita tengok apa yang ubah. Chlorine ni dia ubah position. Alkene masih sama. Okay, and last but not least adalah kita akan change for a different functional group from alcohol to ketone. Okay, so that's the last of it.
Now let's look for the example where we will identify the type of reaction shown by the following equation. So for any given equation, what I would like to do first is actually based upon this molecular formula. What I would like to do is actually I'm going to do the expanded version. So tada! Okay, so this is actually the expanded version. Okay, so let's look for example 1 here. So for example 1, okay, so this is actually our reactant and this is actually our product. So actually from here to here, you have to determine what is the difference. Okay, the new things is actually here. As you can see, suddenly we do have our bromine. Okay, from here we have double bond. Now we only have single bond and we have the addition of bromine. So what happened here is actually an addition process. So I'm going to write down addition. So, but then for the addition, we have electrophile or nucleophile. So, which type? Okay, so from here, actually, it is easier for you to determine based on the site itself. So, from here, is it electrophilic or nucleophilic site? Let's look for the case here. Okay, so that is CC double bond. So, do we have CC double bond on electrophile? No. The carbon-carbon double bond is actually here. So, this is my nucleophilic site. Okay, so since it is a nucleophilic site, so I'm just going to write down here, my alkene is my nucleophilic site. If this is my nucleophilic site, my bromine will be my electrophile. My electrophile. It can't be, ini nucleophilic site, ini pun nucleophile. No. The opposite attract kan. So this is my electrophile. Okay, so from here, how to know what is the addition? So from here, we won't see the site. Kita tengok apa yang ditambah. What we're going to add in this reaction is actually electrophile. So this is actually electrophilic addition. Or sometimes you could also see, senang kan kita tengok tadi bila dekat addition, Addition, electrophilic addition is where the typical reaction of alkene and alkyne. So we know lah, dia adalah electrophilic addition. Up to you mana satu kamu selesa lah. Boleh lah tengok dekat sini. Boleh. Yang itu pun boleh juga. Nak tengok based upon my electrophilic side and nucleophilic side pun boleh juga. Okay, so now let's look for example number 2. Okay, so for example number 2 here, okay, what we have is actually, here our alcohol. Okay, and then we have this reaction. Okay, so what is the differences? It's actually daripada single bond jadi double bond. Dia ada double bond kan yang baru. So I'm just gonna circle the double bond here. And then at the reactant, actually I have extra ni. I have this one. Okay, but on my product, I don't have any H and OH. So what actually happened is that this atom is eliminated. Dah dibuang. So what is the reaction? The reaction is elimination. Okay, so for the elimination, do we have any nucleophilic or electrophilic elimination? No, we don't have. We only have elimination yang biasa sahaja. Okay, so that is for example number 2. Okay, example number 3. Let's look here. Okay, what happened from this one? The number of carbon, the number of single bonds is the same, but the difference is actually from our reactant, we have our OH. From our product, we have our Cl. Okay, so what is this reaction? This is not an addition. Sebab kalau addition, dia mesti daripada double bond jadi single bond kan? We add atom. But what happened is actually, we change the atom itself. So when we changing the atom, the name is actually substitution. Okay, but for substitution, dia ada 3 choices. Ada electrophilic, kita tengok balik sini. We have free radical, electrophilic dengan nucleophilic substitution. Okay, so how do we see it? So we're going to see it in terms of this one. Kita nak tengok electrophilic or nucleophilic side. So here is actually our alcohol. So alcohol ni, kita tengok dekat sini. Is it nucleophilic side ataupun electrophilic side? Alcohol ataupun our hydroxyl, the functional group is actually electrophilic side. So I'm just going to write down, this is my electrophilic side. So it means that my HCl zinc Cl2 ni, this is my kalau electrophilic side, ni nucleophile kita. Okay, so since nucleophile is being substituted into this reactant, so this reaction is a nucleophilic substitution. Okay, ataupun boleh juga kita tengok sebab this is alcohol kan, and then we know that this is substitution. Kat sini dia bagi tahu kan, nucleophilic substitution usually typical reaction of saturated organic compound such as haloalkane and alcohol. Okay, and last one for examples on page 17 ni. Okay, so we have, this is actually our reaction. Okay, so from here it seems a lot of changes. Okay, double bond kat sini, dia double bond kat sini. Okay, tapi dekat sini dia bagi hint is actually at the arrow itself. So this is actually a type of changing into a different functional group. Okay, so from our OH, from our alcohol ni, it become a ketone. So ni lah enol ketone. So yang kalau rearrangement, hint dia adalah the arrow itself. So this is actually a rearrangement reaction. Okay, so for this reaction, actually first, what you have to do is actually draw the expanded version and see the differences. If atom is added, addition lah. If atom is being removed, elimination. Kalau tak ada apa-apa ubah, cuba nampak tiba-tiba kenapa atom je bertukar ni. Dia bertukar, changing, that is the substitution. And lastly is the rearrangement. Okay, but then I'm just going to discuss one more question. Question number 5 ni. So this is actually a benzene. So again, kalau dekat sini, I would like to do the expanded version dia macam mana. Expanded ni, okay, remember this is carbon, 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 carbon. Okay, remember that for each carbon must have 4 bond. So maknanya, each of the carbon here, it have 1, 2, 3. So, what we have is actually kat sini mesti each of the carbon ni ada 1 bond lagi. And then, each of it must have hydrogen. This is my reactant. Okay, my product, again, I want to do it as expanded. make sure each of the carbon tu must have 4 bond. Okay, for the first one yang ni, this carbon, dia memang dah ada cukup dah. 1, 2, 3, 4. But then, the carbon next to it, 1, 2, 3. So, it means that this carbon tak cukup lagi. So, we're gonna do, make sure dia ada bond and it's bonded to hydrogen. So, this is the expanded structure for your benzene. Okay, so actually from here, what is the differences? So, the differences is actually here. From your hydrogen, it will become your CH3. Okay, so is it addition? We don't add anything kan? Tak ada pun, the double bond is still there. Okay, so it's actually a what? So yang ini you could try yourself. Nanti answer Google form. Yang example number example number 6 ni is just I'm gonna help you to do the expanded version. Okay, sebab yang ni si double bond O ni pelik sikit kan. So it means that we have on the same carbon, we have 2 of my CH3, 1, 2. And then on the same carbon, we have double bond O. Okay, and then this is the product. So, in the rest tu, again, do the expanded version. Then I believe it will be easier for you lah to answer the question itself. Okay, so that's it, the last 4 chapter for